So our main focus for today is all about hypothesis testing and estimation. But before we do anything, we need to first understand what is hypothesis, what is hypothesis testing, and how can we do estimations. So hypothesis is basically a stated belief. It can be a belief, it can be opinion, or it can be assumption about a certain problem. So basically that is hypothesis. Any stated belief or any opinion or any assumption you make about something. It's your belief, it's your opinion, it's your assumption. But we cannot confirm your belief. We cannot confirm your opinion. We cannot confirm your assumption about something until we test. So that's why you realize that we need to first know what you have stated as your belief. Then from that, we can go ahead and test whether your belief is true or not. So it means that with hypothesis testing, it's basically a process you're going to follow. A process you're going to follow to confirm the stated belief. You want to do some processes that are at the end of it all, you can actually confirm whether what was stated above is correct or not. So what you state, we always, as we do testing, we always have two opinions. The one you state is always, the one we want to test is always null hypothesis. Null hypothesis. This is the one you state. You as the analyst, what have you stated? This is always defined as H naught. Then we also have the opposite of what you have stated is alternative. Alternative hypothesis, which is denoted as H1. So types of hypothesis, we have null hypothesis. This is always the stated one that is going to be tested. Then at the end of it all, we confirm whether you stated is true or false. If we find that what you stated is false, then the true one will be alternative hypothesis. So as you approach these questions, you should be having that one in your mind, that as I am doing any number about hypothesis, I must be having two options, the null hypothesis and the alternative hypothesis, especially if you want to test the belief. Here there is no much theory. There is no much theory. But as we test, we always also compare two things. You will need the computed value, as you test, you always need the computed value. We need two things. So that is number one, the computed value. Then number two, the value from the table. As we test our belief, we always need two values: the value from the table and the computed value. To get this computed value, we apply some formulas. Then to get the value from the table, we use our tables. And what are these tables? What are these tables we use here? One, you may be using a chi-square table, or you may be using Z table, or you may be using a T distribution table. So it depends on the question you are handling. You use chi-square when you are not dealing with samples. Here, when you are not dealing with samples. Then you use Z distribution table when the sample is 30 or above. Then also here with T table when the sample is below 30. So we are going to start with how can we approach questions related to chi-square. How can you actually answer these questions related to chi-square? And I shared with you the document which we are going to use. So we are going to start with chi-square test. Using our questions. As I said, this area doesn't have a lot of theory. It doesn't have a lot of theory. So you just need to appreciate actually how are you going to answer these questions. Calculation questions. This document has four. I tried to compile four questions. If you can understand all these questions, you will never fail a question about chi-square test. So we are going to start with question 1. And when you observe on the required part, we are told to state the null and the alternative hypothesis. If they say you state the null and alternative hypothesis, you need to first know in this question, has the examiner stated his opinion? Okay, is the person doing this stated the opinion or not yet? So as you analyze, you need it also be knowing that if you realize that he or she stated the opinion or the belief or the assumption, that belief is null hypothesis. Then the opposite of what that person stated will be your alternative hypothesis. Then we need the expected values. Once you get the expected value, we are told that we determine the value of chi-square test and interpret the output obtained from the statistical test in terms of null hypothesis at 5%. So as I said, when we are testing, we are actually testing null hypothesis to confirm whether this researcher, what he stated, what he or she stated is actually true or false. So as we do testing, we are actually testing the null hypothesis. If we confirm that null hypothesis is true, then we accept the null hypothesis. But if we confirm that the null hypothesis is not true, then we accept the alternative hypothesis. Okay? So basically, you are trying to test what the researcher stated in this question. So we analyze our case study and see, we come up with the information that is going to help us. Okay? They are telling us that the Adolescent Research Study Center in the Ministry of Gender and Labor conducted a research on teenagers and media technology. The research center offered teenagers access password to their media raw data sets for research. Of course, you need data, and for you to get data, you must first seek for the access to this data. Without access, of course, you cannot get data, cannot get information. They are telling us that a random sample of Uganda urban residents was selected to complete a questionnaire for each of their children between and including the ages of 13 and 15. It is 13, 14, and 15. Parents of the teenagers were asked, do you know your child's password for any of his or her social media? That is the question the researcher was trying to find out. The responses to this question were received from 493 family residents, as indicated in the table below. We have parents' response, those who confirmed that they know the password, where you have yes, and those who confirm that they actually don't know the password of their child's social media platforms. Here we have age, 13, 14, 15. Then we have this column total. We have also this row total. If you add this row total, you get this. If you add column total, you also get this. But in some questions, you will always find that sometimes you are not given this column total, you are also not given this column row, rather this row. So in a situation where you are not given such totals, you will be the one to create this row total, you will be the one to create this column total. So this is the observed data, what you have. This is the observed data. For child with 13 years, you observed yes as 76, then no as 66. Then for 14 years, you observed this, and for 15 years, you observed this. These totals are not observations. These totals are not observations. And also these totals are not observations. What you actually observed are these ones in red. Okay? And they are telling us that a test of significance is to be undertaken to find out whether there is an association between a parent knowing any of their child's social media password and the age of child. Are you seeing that? I want you to appreciate these things because students have bias on these areas, yet they are very easy. And in an exam, they don't take a lot of time. Once you know the concept, that's all. You will use like 10 minutes to complete the number. Don't be biased on these what? On these topics. They are very easy. Just you need to appreciate the concepts. So here they are telling us that a test of significance is to be undertaken to find out whether there is an association between a parent knowing any of their child's social media password and the age of child. So basically, this is what the researcher wants to test. He or she wants to confirm whether parents actually know the password. So what is stated here in the question here is your null hypothesis. Then the opposite of what is stated here is your alternative. We are going to state the null and the alternative hypothesis. So you can get your book. This is question 1. This is question 1. And our hypothesis now, number 1, is the null hypothesis. We always start with the null hypothesis. And we are told that here the null hypothesis is there is the null hypothesis. We are told there is what? There is that. There is an association between a parent knowing any of their child's social media password and the age of the what? The age of the child. Then number 2 is your hypothesis, rather your alternative. Number 2 is alternative hypothesis. And with alternative hypothesis, we are just going to say there is no association. We are going to say that there is no association between so this is our stated hypothesis. Based on our question, someone who in the chat is saying is not getting this one clear. I said, we always, as we start, maybe the person missed the first concept. Someone is saying, I can't hear anything, Warai. Maybe you need to first quit, first leave the chat and log in again. So someone who is saying it is not clear, we are saying null hypothesis is only that belief. As we said, hypothesis is a stated belief, opinion, or assumption about a problem. Now, the problem is what? The problem is all about knowing the password. We want to find out whether these parents, we want to find out whether these parents know their child's password. But of course, this hypothesis is categorized into two. That is null hypothesis and alternative hypothesis. Whereby the null hypothesis is that assumption, is that belief or opinion stated in the question. What the researcher has stated is null hypothesis. Then the opposite of what is already stated is your alternative hypothesis. Like when you go back to the question, this is what is stated. They told us that a test of significance is to be undertaken to find out whether there is, here you have a site, there is an association between a parent knowing any of their child's social media password and the age of child. So it means that what is stated here is your null hypothesis. Then the opposite is your alternative hypothesis. So if you say there is an association, then opposite of this is there is no association. Okay? Are you all clear about the stated hypothesis? Are you all fine? Perfect. So we are done with Roman 1. Now we go to Roman 2. Roman 2, they are telling us that we compute expected values from the data. Why do you need these expected values? You will use these expected values when you are even answering Roman 3. As we said, with chi-square test, basically, we are going to be using chi-square table. And our focus is not all about samples. Our focus is not all about samples. And if our focus is not all about samples, what should be our focus? Our focus here, our focus is just to know the expected values, that is E, and the expected value, that is E, and the observed values. That is basically what we are interested in, observed values. That is O. So it means that you will analyze the question, from your question, you needed to know your observed values. You need to know your observed values. Then you needed to know how can you get the expected values. The observed values is what you actually observed, you as the researcher. From the data, what did you actually observe? So it means that observed values will always be given in the question. But it's your role, you are the person handling this question, to get the expected values. You are the researcher. Okay, you observed some data. But as the researcher, what did you expect to find? Because as we do research, we always observe something, but as observers, we also be actually be having our expectations. What did you actually expect as you're going to find out the data? What was your expectation initially? Hmm? So that is basically what we are trying to, that's basically what we are trying to get. This one, because it is not given. What is given is observed the values. These are our observed values. So on every point, on every observed value, there is what you expected. On every observed value, there is what you expected. So how are you going to get the expected value here? How are you going to get the expected value here? How are you going to get the expected value here? How are you going to get the expected value here? How are you going to get the expected value here? How are you going to get the expected value here? That's what we are trying to find out. That's what we are trying to find out. So, and it is very clear. To get the expected values, we will be getting, especially if you have data in that form, you will be getting, to get expected values, this is the formula that we use. Row total times column total, then divided by overall total. So if you don't have row total, you need to get row total. If you don't have column total, you need to get column total. But in this question, you observe like at this point where you have 76, what is the row total corresponding to 76? When we are talking about row, this is row. Then this is column. So what is row total corresponding to 76? Row total is 218. Then what is column total corresponding to this 76? It is 142. And how do you get these totals? You just get the observed value. Get this one plus this one. To get this plus this one. This plus this one, you get 173. Then to get the value this side, column total, you get what you have here plus this plus this. You get this plus this plus this, you'll be in position to get. So basically, to get our expected values, here, I need the expected value here. 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 I need the expected value here, also here. We are saying follow the formula. Row total times column total divided by overall total. So how are you going? Just follow the formula. We are saying row total. What is your row total? It is this one. 128, 218. Then we multiply by the column total, which is 142. Then the answer we get, we divide by the overall total, which is this one. Which is 4, 493. What do you get? 3. What about here? You do the same. Row total is this one times column total, it is this one, then divide by this figure. It is 79. What about here? Row total, it is this one, then times this, divided by the answer you get, divided by this. What do you get?
76.
76. Point what? Let's round off to the whole number.
It's 0.05. 76.
What about here? I need another person to tell me the figure here. We are getting row total, which is this one, times column total, which is 142. Then the answer we get divided by. What do you get here?
79.
79. What about here?
$99.
This is 90. 99.
9.
What about here? I need a guy. Jimmy. What do you get here? We are getting this figure times the column total, which is 173. Then the answer we get, we divide by 493. So which is approximately what? 90 what?
97.
97. Perfect. So you observe that if you add these values, your expected values, you will still get this total. If you add your expected values here, you will still get this total. Even if you do in column form, if you add this plus this, you will still get this total. If you add this plus this, you will still get this total. So let me hope that you have understood how we get expected values. If there is a question, ask. Ask. This is the overall total. When we get this plus this plus this, you get this. When you get this plus this, you get this. That's why we call it the overall total. So those are your expected values. You have answered Roman. You have answered Roman 2. You have answered Roman 2. If they say you construct a contingency table, if they say you construct a contingency table showing your expected values and observed values, what you're going to do, what we are going to do is to contingency table. For contingency table, we draft again our table. Then you put it in a box. You can just construct it somewhere, a little box. Box, put observed value. Do the same here, put a box. Then in your box, you put expected value 77. Then below that box, you put observed value, which is observed value. You just go to the question. I believe you will complete the contingency table, isn't it? Isn't it, colleagues?
Yes.
expected values, put them in the box. Then below the box, put observed value for every value. Here, put expected value in the box. Then below the box, put observed value. And that will be all for your contingency table. A contingency table should show your, at every point, should show your expected value and should show your observed value. So I'm done with that. We go to the next question. Our next question, Roman 3, they are telling us that we determine the value of the chi-squared test and interpret. This is the computed value. If they say you determine the value of the chi-squared test, this is the computed value. Then after computing that, you're going to interpret the output obtained from the statistical test. The output you're obtaining is the one from the table, the value from the table. So you are going to interpret that by comparing it with the computed value. So let's first get the value of the chi-squared test or the computed value. And when you're getting the computed value, the value Roman 3, we need the value of the chi-squared test. This is like the computed value of x squared. And how do you get that value? How do you get that value? You guys, do you recall the formula? We get summation. Summation what?
Sum of observed minus
Summation of observed values, then minus expected
value,
then squared. This should be squared. Then everything you get, you divide by what? By
expected
value. So it means that we need to create our data in a column form. We need to create our data in a column form. I will put here my observed values. Then I will put here my expected values. That is it. This is O. Then I will need here my computed value, which is x squared. And the formula we follow here, it is this one. So we can actually put our observed values, all of them. We first list all of them. Observed values from our question. What is the first observed value? It is now you are going to change. If you can decide to change a row to become a column, This is your row. You can make it a column, or you can decide it to work like this in a column form. First write this, then you write this, then you write this. But what is advised is just write first write this in a column form. Then after writing all these values, go ahead and also write these values. So we are going to start with 76, then we will go to 75, and how you will be telling me. This is 70. The first one is 70, 76.
70.
Then the next one is
75.
75, then followed by
67.
next,
66,
66.
then next,
103,
103, then finally
106.
106. Perfect. So you do the same for your expected values. You do the same for your expected values. So here my first expected value is 63. This
63,
is 63. Then next,
79,
this is 79.
76,
76.
76, then
79,
70.
then next,
99,
99.
then finally
97.
97.
97. Once you have that, you apply in the formula. Open bracket on your calculator. You open bracket on your calculator, then write the observed value 76 minus 63, close bracket, then click on squared, or you say power 2. Then you press on equal signs. The answer you get, divide by 63. What do you get? Let's round off to 3 decimal points. What do you get?
2.683.
683. Colleagues, that's what you all have.
Yes.
Then what
Yes.
is the next value?
It is 0.2.
Yes,
03.
03. Then next. Another person can start from bottom, as just to be fast. We need the summation. We need the summation of this. We need the total. What is the total?
Good morning. Do you know what a story is? It's okay.
Add
Stop.
everything.
Uganda skin codes.
493. 493.
Just
So what is the
there
key
is
for?
no point.
What is the key for the lower class here?
No, the expected values.
How are you getting this? You add. I'm saying add only this.
Oh.
We don't need these totals here. We don't. We just need the total on the last column. Just add
It's
new
7.
value.
It is 7.088.
7.088. That's
88.
what you all have.
Yes.
Yes.
Please, if you're not getting how these values were calculated, ask. Are you all fine with getting these values? Please, I'm very slow because I don't want to repeat this area. I'm very slow. Understand it and you call it a day until you do your exams. So the value we have is our computed value. The computed value, that is x squared is equal to this figure. Is equal to this figure. So we are done with that part. So it means that we need now the next step. We need the value from the table. I'm very slow, but I need you understand these concepts clearly. How are you going to get the value from the table? How are you going to get the value from the table? To get the value from the table, you will first know your basis. You will first know your basis. Remember the table we are using. The table we are using is that table for chi-square. So in your question, you will always find that you're given tables. You'll find that you're given tables, and the first table shows Z. It is the cumulative normal distribution, that is Z table. Then the next table is chi-square distribution. Are you seeing that, colleagues? Then you will always also find that you have another table, which is T distribution table. But the fact that we are dealing with chi-square, we are going to be using this table. We are going to use this table. And when you observe this table, the first column has a V. And this should be your standing point. Before you do anything, you need V. Then once you have V, you need to ask yourself, what is Q? What is your Q? Or what is your basis? What did you set as your level of significance? And in our question, you can observe that. You can observe that our level of significance is 5%, which is 0.05. 0.05. Okay? Then our... How do we get V? To get V, that is degree of freedom. Degree of freedom, V. V is degree of freedom.
All right then. All right, sir.
Degree of freedom. Freedom, is it double F, double E? It will be equal to number of rows minus 1, then times number of columns minus 1. Number of rows minus 1 times number of columns minus 1. Where are you getting number of rows? From your observed data. how many rows do you have? Then how many columns do you have based on your observed data in the question? How many rows do we have in this question?
We have 6.
We have 6.
We have 6 rows.
Yes.
Yes.
We are picking this from the question. We are not picking this from this table. No, we are not picking this from this table. We are picking a number of rows from our question. We are picking a number of columns from our question.
We have 2.
So number of rows are how many?
2.
There are 2.
2. We get 2 minus 1. Then number of columns are how many?
Yeah, 3.
There are 3.
That's 3.
3. Just where you have observed values, don't consider those don't consider those column totals, don't consider those row totals. So what do you get? This is 1 times 2.
You get
And
2.
finally your V is 2.
Is 2.
Any question about how we get V? Now, the next step is to see our basis, our percentage, our level of significance. Our level of significance. They told us that level of significance is what? 5%, which is the same as 0.05.
0.05.
Now, the question is, do we divide this by 2 or we leave?
We leave it.
Do we divide it
leave.
by 2 or we leave it?
We leave it.
When do you divide it by 2?
When it's a 2-tailed test.
When?
It's a 2-tailed test.
When it is two-tailed test. When it is two-tailed test. Because two-tailed test comes from where, or one-tailed test comes from where? That it depends on your null hypothesis. It depends on your null hypothesis. Okay, at first, do you have side? Yes, I have the side. I have the side, which is association. I have the side, there is association. Here I have the side. And the moment I have the side, it means that I am focusing on that side. I'm focusing on only this one side. But if I realize that I don't have the side, then that will be our two-tailed test. As you're going to see moving forward, as we advanced other questions to, let's say, Z test, let's say T test, you are going to actually be seeing that some situations we divide by 2. That is level of significance, we divide it by 2. And in some situations, we don't divide it by 2. But the concept is basically on whether at first you had a side or not. If you realize that you had a side, then that will be one-tailed test. But if you don't have a side, you don't know whether you should focus on negative, you don't know whether you should focus on positive, as we are going to see. So here we have the side. Here we have the side. So we cannot divide it by 2. We cannot divide it by 2. It means that when you observe, this is always like alpha. When you observe our Z table, our chi-square.
Excuse me, Abby. Come again on the one-tailed test.
One-tailed test. That is a situation where in the question they have given you the side. You are not the one choosing the side. You have already the side. That is, there is association. That is the side. You have the side in the question. But if you don't, if you have the side already indicated in the question, then we don't need to divide by 2. But if they have not shown you the side, then it means that we cannot actually tell whether we should focus on it is always left and right. Our table, we will see that our table will always be having right and left. But in this chi-square, most of the times you'll be having the side. It is with Z table and a Z distribution table and T distribution table where most this concept will be applied. As we advance, you are going to understand more. Just so that this is a start. This is a start. So here we don't need to divide. We don't need to divide. So we go back at our table. Go back at our table. You see, I want you to observe why with chi-square we don't actually need to divide this. You see our chi-square. Our chi-square. This one has this table. There is this diagram. There is this side right, then there is this side left. Even a T distribution has left side, then it has also right side. But here, nothing. Here, nothing. So, what does this one mean? What does this one mean? We are going to stand. We are going to stand where we have V. What was our V?
2.
Our V is 2. This is 2. We stand here, then we move horizontally. We look for where we have 0. What was our level of significance?
0.05.
0.05.
5% divided by 100 is 0.05. So you move horizontally, then look for where you have 0.05 from these values on the top here. So where you have 0.05 is here. So the meeting point is 5.991. So the value from the table, that is x squared from the table is
5.
We said it is what? 5.991.
5.991.
Have you all understood how we get the value from the table using chi-square?
Yes,
You first
Abel.
get V, then know your level of significance. Go to your table. Stand where you have V. V is 2. Then move horizontally, look for your level of significance. Okay. Then finally, you see we have the value from the table. We have also the computed. We have the computed value, and we have also the value from the table. So we can compare the two values. We can compare the two values and confirm whether we should accept null hypothesis or we should reject null hypothesis. That is interpreting your result. Now we need to interpretation. Colleagues, if this question comes and you fail, you will not be my friends. Not be my friends. I'm very, very slow. People have bias on these things. People have bias, and the examiner is aware. Examiner is aware that people don't actually appreciate this. When you read the examiner's comment, you will see such a comments. When it comes to hypothesis, when it comes to probability, people have bias on those topics. Yet these topics are very easy. If you understand them, you find that you are not wasting a lot of time. You need only 10 minutes to finalize the question. So how are you going to interpret, or how are you going to make conclusion? How are you going to make the conclusion? You are going to be comparing two figures. You are going to be comparing two figures. You are going to compare the computed value. You are going to compare the computed value with what? The value from the table.
With the table value.
Compare the value from the table with the computed value. If the computed or the calculated value, if the computed value if the value from the table is greater than the value from the table is the tabulated value. That is the value from the table. If it is greater than the computed value, what do we do? Do we accept the null hypothesis, or we accept the alternative? Then we are also going to ask ourselves if the value from the table is less than computed value. Are you going to accept the null hypothesis, or you are going to reject the null hypothesis? So colleagues, if the value from the table is greater than the computed value, you are going to do what? So you guys, you mean you have never heard about this?
You're going to
We
reject.
don't know.
You don't know. Okay. That's why you are here.
We don't know, Abin.
That's why you are here. Someone in the chat is saying what?
You accept.
First put the formality. Then here. So it means that here you are saying we reject.
Yes.
When we use this concept, most students don't get it clearly. So what will help you? Always draw your diagram. Always draw your diagram. So we need to ask ourselves. Of course, you'll also be having the same. You'll also be having the same this side on left. On left, maybe you create a gap. You have one. Let me also put it here. I'm doing for
Exceeds.
it exceeds, isn't
It
it?
exceeds.
If it
Yes.
exceeds, automatically, if it exceeds, automatically we do what?
You reject.
I still have a long journey to do this thing, these
You
numbers. If you realize that the computed value exceed your region here, does not fall within this and this, you are going to reject.
You reject.
Does it make sense? The diagram, does it make sense? Because
Yes.
programming this one may not bring it clearly. But if you use this diagram, can help you very fast. It can help you very fast. If the computed value falls within this region, this one between this and this, you accept. Let me just even shade it again, so that you don't forget. If it falls within this region, we accept the null hypothesis. But if it falls outside, if it is outside, we reject. I believe the diagram makes it clear instead of using these ones, isn't it?
Yeah.
Always use the diagram, it can help you very fast. Just put the value here, put also the value here. If the value you put here as positive, also put the same value here as negative. Then ask yourself, is your computed value within this region? If the answer is yes, then you accept null hypothesis. If it is outside this region, you reject. So also here, the people who suggested this, we are correct. But you see, it doesn't bring it clearly, isn't it? This one doesn't bring it clearly. So its choice is yours to either go with method 1 or method 2.
Abel,
Yes, please. I'm not getting you.
the method
Please, you are breaking also. If computed value, is it my network or the other person's network?
The other person's network.
If the computed value fall within the acceptance region, accept null hypothesis. Then if the computed value does not fall within the acceptance region, we reject null hypothesis. So someone in the chat is saying, I'm not getting method 1. If you're not getting method 1 and you're getting method 2, just go with the easiest one. Unless if you say even method 2 is not clear. Is method 2 clear to you? Because method 1, we are saying if the value from the table, what is the value from the table? This one is greater than, if it is greater than the computed value, you accept the null hypothesis. You realize that using this diagram, if the value from the table is greater than the computed value, you will realize that the computed value falls within the acceptance region. That is, if this value from the table, if this value from the table is higher than the computed value, it implies that your computed value will fall within the acceptance region. That's why even here we are saying accept. But if the value from the table is less than the computed value, like our question here, this is the value from the table, it is less than the computed value. So we are saying reject. Is it clear, colleagues?
Yeah.
Yes, it is.
Yes.
So in conclusion, our conclusion, therefore, we can conclude that, here, no, we are not accepting, isn't it? From our interpretation, we are not accepting this computed value falls outside the what? Outside the acceptance region.
We reject.
So therefore we reject. We reject null hypothesis and accept. If you reject null hypothesis, it means that you are accepting what? You accept alternative hypothesis. And if at all we accepted the null hypothesis, meaning that rejecting your so hence what was now once you state this, bring in the statement talking about null hypothesis. Conclude with that statement. No, conclude with that statement. Once you state this ground, we are rejecting null hypothesis, and accepting alternative hypothesis. So it means that in the conclusion, we conclude and say that what was the alternative hypothesis? Hence, you say hence, now put this statement. Because we are accepting this, So we say hence, there is no relationship. Because this conclusion you are putting here is your alternative hypothesis. The conclusion you put here must be that conclusion relating to accept. What are you accepting? Are you accepting the null or you're accepting the alternative? Here we are accepting the alternative, so we conclude with the alternative statement. And that's all with this question. It had 12 marks. Any question? Any question? Do you need more clarification anywhere? Oh, that's enough. So, with this background, other questions will not take a lot of time with this background. Other questions will not take a lot of time. Actually, when you observe this conclusion, colleagues, I can also accept this. Big percentage of parents actually do not know their child's social media password, isn't it, colleagues?
Yes.
Yes, ideally, you can also observe that parents actually do not know. Unless if here we have one person who shares the password of WhatsApp, of everything, TikTok. Do you share with your parents? So, question 2. Question 2. So, question 2, they are telling us that you state, required part, they are telling us that you state the hypothesis you would apply. Examine the validity of this belief. Then number 2, you are test the chairperson's belief at 5% level of significance. So we needed to know this chairperson, did he state his opinion? Did he state his belief? So we read our case study. The chairperson of the Public Accountants Examinations Board at ICPAU, that is Institute of Certified Public Accountants of Uganda, believes that gender is independent of performance in the accounting profession. Okay, before we proceed, colleagues, do you believe that? Do you believe in that statement? That the gender
Yes.
is independent of performance in the accounting profession. Are you sure that ladies perform more than
No.
Oh, guys perform better than ladies? Do you believe in that statement?
No.
Ladies perform better than men.
Because you are a lady.
No, it is just
Generally, according to our results that are normally released. But as we said, colleague, this is just a statement. This is just a statement from the chairperson. the chairperson of Public Accountants Examination Board, is saying that the gender is independent. If the word independent means that it does not necessarily mean that the male or female perform better in the what? In the accounting profession. Gender is, we don't actually rely on those things of gender or what. There are other factors. There are other factors that may actually result in this performance. Basing on maybe your tutor, basing maybe on the way you put in time, personal revision, practice. So it's not basically about gender. That is what actually this chairperson of Public Accountants Examination Board at ISPA is trying to mean. Are we together? It doesn't necessarily mean about gender. If you're a male and you don't read, you will fail. If you're a female and you don't read, you will fail. You will not perform. So there are other factors. So to confirm, now we want to confirm whether his belief, for him is saying that the gender is independent. It does not contribute anything to the performance in the accounting profession. To confirm, we want to confirm. So when you're stating the null hypothesis, this is your null hypothesis. Gender is independent of performance in the accounting profession. That is your null hypothesis. The hypothesis stated in the question. The hypothesis stated by the chairperson. That is our null hypothesis. So what is the alternative? Who can now state the alternative? What is the opposite of independent?
Alternative is dependent.
Alternative is dependent. So you say for alternative, we state hypothesis. Number one, we always start with null hypothesis. Don't cram these things, just understand, because your question in an exam will be different. Okay? If authority is there. We are saying gender is independent. Gender is independent on the performance, in the accounting profession. Or another person can say the performance in the accounting profession does not depend on gender.
But Abe,
Yes?
don't you think that those statements are the same?
Pardon? You are saying these statements are the same. Yes. One student can say for my null hypothesis, gender is independent on the performance in the accounting profession. Or another student can say my null hypothesis is the performance in the accounting profession does not depend on gender. That is your null hypothesis. So you choose any of those. You choose any. So we go to the alternative. Alternative. alternative hypothesis. And this is always your H0, H1. H1, this is H0. So what can be your alternative hypothesis? Gender is not independent on the performance in the accounting profession, or the performance in the accounting profession depend. So you just change the words. Gender on the performance in the accounting profession. Then, or another student can say the performance in the accounting profession depend on gender, which is not ideal. But you cannot say it is not true until you test. So it means that this is your stated hypothesis. You're done with Roman. You're done with Roman 1. Done with Roman 1. So we go to the next. Now we want to test. We want to now test, confirm whether what the chairperson stated is true or false. Remember, for this chairperson, he stated this, that the performance in the accounting profession does not depend on gender. That's what he or she stated. That's what was stated. We want to test to confirm whether it is true or false. And as we test, we need two things: the computed value, and the value from what? Value from the table. Those are the two values you need to confirm whether null hypothesis is true or false. You can either start with the value from the table or you start with the computed value. Order does not matter. What matters is to answer correctly. Because they said we test the chairperson's belief at 5%. So we need to know what is our observed data, what is our expected value. To confirm this belief, a random sample was taken comprising of 200 males and 160 females who had completed the CPA course. The results are summarized in the following table. I think you cannot wait to complete. Where will you take your graduation? The CPA course. So here, this is our results. This is our data. You have male, you have female, but the data you have, colleagues, is in a percentage form. Remember, we are always interested in numbers. We are always interested in numbers, in values, not percentages. Are we together? So every time you're given percentages, you must convert from percentage to numbers. So this is the observed data, but in terms of percentage. We need observed data in terms of numbers. So you will have to convert from percentage to numbers. Do you know how to convert? If it's male, you know the number, you know the total number of males, you know the total number of females. So it can be easy to convert to numbers. So our observed data or values from percentage to numbers. How can you get the number here? What are you going to do? You just get the percentage, this percentage time. First confirm whether you get this plus this plus this, whether you get 100. Do you get 100? This plus this plus this. First confirm.
Yes, you got 100.
Yes, it's 100.
It's 100. So to get the number, just get 18.5 over 100, then times what is total male?
200.
So multiply by 200. What
It's 127.
Just tell me. For female or merit?
Yeah,
Merit is what?
127.
127. Where am I? This is 127. Then here,
36.
then for female, 27.5 over 100 times. This is over 100 times. How many females?
160.
And the answer you have is
44.
44. Then what about here?
96.
96. What about here?
20.
Pardon? What do you have here? What do you have?
20.
So that is our observed data in terms of numbers. So from here, you see that we cannot get expected value minus
Totals.
totals. So
My
create column total, then also create row total. This is total. This is total. What do you get here? Get this 37 plus 44. What do you get this side?
81.
81. Then if you get this plus this,
223.
223. What about here?
56.
56. Then if
56.
you, then I need the total here. Column total. This is 200.
200.
Then
Yes.
here,
160.
then overall total. This total is
360.
this is
300.
if you get this plus this, you must get also 360. And this is your overall total. This is your observed. This is your observed data. This one in red. This is your observed data. So at this point, can you actually answer? Because we have everything. Like the way we did this, you can now get expected values. After expected values, you can create this table and look for the computed value. Is it hard? You want to withdraw or you will
It is
finish?
not.
You will finish, eh?
We can try.
We do.
Oh, we do.
We do.
Yes.
So we need expected values. How do you get expected values?
Row total times column total.
And from total.
Wait. Our formula is here. Our formula is here. Our
Yes.
formula is here. We can use this formula to fill this table. Let's use this formula to fill this table. The first one is what?
45.
45. How? Those who have just joined, how you get row total, which is 81, times column total, which is 200. Then the answer you get divided by overall total, which is 360. So what do you get here? 45, then here, put some speed.
36. 36.
Then here,
124. 124.
124. Then here,
99.
99. Then here,
31.
31. Then here.
25.
Colleagues, are you getting the same values? Once you do that, the next is to draw this table to get the computed value. Next, get computed value, that is x squared. And draw this table the way it is given. Just you remove these values because they are not correct and put the correct values. What is observed? What are your observed values? Copy and paste. The first one, I said you always change the row to become a column just to make your life easy. This is the row, change it to appear as a column. This is starting with 37. Next one is 44. Next one is what?
127.
127. Next one is what?
96.
96. Next one is what?
36.
36. Then the next
20.
20. Then next
Total. Done.
done. Then do the same for expected value. These are your expected values. This is a row, make it a column. 45,
36.
36. Then
124.
go to the next 124. Then
99.
31. Then 20, 25. Someone who to do this very fast using the formula. The formula is this one. Open a bracket on your calculator, write 37 minus 45, close bracket, click on x squared or just put power 2, then click on equal sign, the answer you get divided by E, which is 45. What do you have here?
1.422.
1.442. 3 decimal points.
1.422.
1.422. Perfect. Then the next one.
Yeah.
Next figure. Please.
1.778.
1.7.
1.7777.
78.
777. So it is 77.
It's 5.17.
5.17.
7.
Only.
Yes.
All right. So this is our computed value. We can get the value now from the table. Value next is value from the table. Value from the table. How do we get the value from the table? We repeat the same procedure like these ones. Like here. These are the steps we follow to get value from the table. Do you know the number of, do you know degree of freedom? Degree of freedom is V. Do we how many columns, how many rows do we have in this question? Remember, we observe the number of rows based on our observed values. Our observed values. Always check the question. Always checking the question. This is the observation. This is where we had. This is where we had observations. Only this one. So you have how many rows? 1, 2, 3. How many columns? 1.
2.
Yeah, 2.
So you get 3. Number of rows are 3 minus 1. So you multiply by number of columns 2 minus 1. This will be 2 times 1, which is 2. Then what is our level of significance? Level of significance. What is the percentage given in the question?
It is 5%.
It is 5%. So that is alpha, which is equal to 5%, which is approximately equal to 0.05. So you can actually read the value from the table. I think it's the same like the first question, because V was 2 and also level of significance was 0.5, isn't it?
Yes.
So that value from the table was what? Those who have just joined, those who have just joined, we said to get value from the table, you will check your chi-square table. On your chi-square table, this is where you have chi-square distribution. V is 2. V is 2. Move horizontally, look for where 0.5 is. 0.05 is here. So we are writing 5.991. Someone is saying the second last computed value is wrong. Have you confirmed? Please confirm. So value from the table is 5.119. This one, move horizontally. It is 5.991. 991. That is the value from the table. Colleagues, have you confirmed that our computed value is correct or it is wrong? Which value is wrong? This one?
The second last.
This one?
Yes.
It
It's
is what?
supposed to 0.0806.
0.0806.
Yes.
So it means that it is 0.081, isn't it?
Yes.
So you get now the total, the right total. Please, this paper, people fail because of calculator, I may say. One of the reasons why some students may fail this paper is also because of how you use your calculator. How you use your calculator. So tell me the total if you sum up very fast. Colleagues, you are quiet. What's up? What's up? What is the total here? You changed from correct answer to wrong answer. Now you are confused. Now you are
The correct
confused.
answer is 0.806.
0.806. That is the correct answer. Please get your calculator. Write open bracket 36 minus 31 close bracket. You click on where you have x squared. Then the answer you get divided by this.
It is like that.
Then the total
5.17.
7.17. 5.17 is the you need to learn how to get the right things. Your tutor, your lecturer, your discussant will not be with you in an exam using the calculator. You will move out saying that kapepa nakakubye, yet you used your calculator wrongly. So be very attentive. This is the right figure. So we have the value from the table, we have the computed value. So the question is, are we accepting the null or we are accepting the alternative? Is this figure higher than the computed value? The value from the table is this one. Let me first confirm whether the value from the table is correct. Yes. So are we accepting the null hypothesis or we are rejecting?
No
Remember
hypothesis.
remember our conditions. These are three methods. These are three methods that we use. So the question is value from the table greater than the computed value or not? First tell me, is the value from the table greater than the computed value? This is the value from the table. Is it greater than the computed value? The computed value is this one. So it means that this value is greater than this one. And if it is greater, we accept
We
what?
reject.
Ah,
We accept.
don't rush. We accept. We accept. Don't rush. Right? So it means that our question we are accepting. If this is confusing you, use method 2. Press here 5.991, because this is the value from the table. Then ask yourself, is the computed value within the acceptance region? We see that 5.17 actually is below this figure. So it is within the acceptance region. And we said if the computed value fall within the acceptance region, we accept what? Null hypothesis. Is it clear, colleagues?
Yes.
We are not rejecting. We are not rejecting because the computed value is 5.17 and the value from the table is 5.991. 5.17 falls within this region. It does not exceed this value. So it falls within this region. So if it falls within the acceptance region, we are saying accept. So therefore, we accept the null hypothesis and reject alternative hypothesis. Hence, bring the statement that was on your null hypothesis. What is that statement? We can say, hence, the performance in the accounting profession does not. You just copy the statement that was on null. Remember when you put here hence, we said put the statement that corresponds to accept criteria. The first question, we accepted alternative. We accepted the alternative. That's why you see on alternative, we had to put this. Here we are accepting the null, and that's why you see we are copying the null statement. Therefore, the performance in the accounting profession does not depend on the gender. Is it fine to you all? Have you understood this concept? or there is something confusing you? Or you are waiting to understand during exam? So we are done with question 2. We go to question 3. Question 3. They are telling us that in a sampling survey, it was anticipated that the outcomes KLMN will have probabilities 1 out of 5, 3 out of 10, 1 out of 10, and 2 out of 5. If you add these probabilities, you must get 1. And they are telling you respectively. So the probability corresponding to K is 1 out of 5. Probability corresponding to L is 3 out of 10. The probability corresponding to M is 1 out of 10. Then the probability corresponding to N is 2 out of 5. They are telling you that 40 independent repetitions of sampling results were obtained as follows. This is your outcome, KLMN. These are results. So this is like the observation. You have 11, 14, 5, and 10. They are telling they are telling that if chi-square goodness of fit test is used to test the hypothesis at a significance level of 0.01, state the null hypothesis applicable in this test. How do you state now the null hypothesis? How do you state the alternative hypothesis?
We are trying to analyze.
You are trying to analyze.
Yes.
So colleagues, in such a kind of questions, when it comes to stating null hypothesis and alternative hypothesis, if you're given probabilities, if you're dealing with a question with probabilities, because you see, like the first question, the first 2 questions, we had no probabilities anywhere. But here you are dealing with the question which has some probabilities. What does this one mean? You see, it is hard for you actually to come up with those statements where formulating under null and alternative. But what you can observe are actually probabilities of each outcome. And remember that these probabilities can change. Isn't it, colleagues? We all know that probability, you may anticipate that my probability for K will be 1 out of 5. My probability of L will be 3 out of 10. This is your anticipation. This is your prediction. it was anticipated that the outcomes. So this is what you expect. This is what you have stated as your expected probability, as your expected probabilities, or your predicted probability. So it means that actually what is anticipated is your null hypothesis. Because we know that probabilities can actually change, we want to confirm whether these probabilities are correct or not. This is what you have anticipated, but we want to find out at the end of it all, is what you anticipated correct or not? So don't cram things, just try to understand. So it means that as we formulate our hypothesis, one, null hypothesis, null hypothesis will be your expected probabilities. What do you anticipate as your probabilities? Null hypothesis. This is H naught. What do you expect as your probabilities? What have you stated? The probability of K, you are saying it is what? In the question, the probability of K is what?
No, 1/5.
1/5. 1 out of 5. Then the probability of
L.
what is the next? KL. The probability is what?
3
Yeah.
out of
Of 10.
3 out of 10. Then next, probability of
M.
M.
which
1
is
out
equal
of
to 1 out of 10.
1.
Then next, probability of
N.
what is our last one?
Yes.
2/5.
Our last one is what?
N.
2/5. It's N.
Which is
2/5.
2 out of 5. So this is your null hypothesis. You are saying that the probabilities, you anticipate them to be like this. But we know that these probabilities may not be these ones. So as you state your rather your alternative, as you state your alternative hypothesis. Colleagues, is my network clear?
Yes.
It is.
As you state your alternative hypothesis, you are going to say, for you to your side, you're going to say that this probability is not true. This probability is not true. You are just opposing. Because we said that alternative is just opposing what? Null hypothesis. If you stated that the probability of K is equal to this, the probability of error is equal to this. Now, what should be your alternative is to oppose, is to say that, no, with alternative, I'm saying the probability of K is not equal to this. That's what you are going to state. Probability of K, M, is not equal to 1 out of 10, and the probability of n is not equal to 5 out of 2 out of 5. Are we together, colleagues, here? You are just trying to oppose. You are just trying to oppose. So this is your stated hypothesis, null and alternative. We need now to test. We need to test. We need to test because they said we calculate the value of chi-square statistic. That is the computed value. That is the computed value. And hence determining the decision reached. So the decision reached will be based on your computed value and the value from the table. So that test, you need a computed value, but do you have observed values? You need a computed value, and the value from the table. And the value from the table, you will use the portion given in the question, which is 0.01. You will need V. We are going to see how you can get V. But how are you going to get computed values? To get computed values, you need observed values, you need expected values. So what does this one mean? What does this one mean? We are going to see our question again, analyze it clearly. This is our observation, because they said 40 independent repetitions of the what? Of sampling results. These are your results we are obtaining. So this is your observed data. This is your observed data. So since this is your observed data, how can you get the expected value point? Let's get because we have observed data in numbers. Now we need expected values. How do you get expected values with this kind of question that has probabilities? You will not use the other concept of saying row total times column total divided by overall total. That formula will not apply here because you have probabilities. And if you have probabilities, you need to know, are you given the overall total? That is the total. Remember, to get the expected value, it is always n times what? N times p. So this is the formula you are going to apply when you're given probabilities. This is the formula you are going to apply. So on every observed value, we can get expected value by applying this formula. We can draft like a table. We can draft our simple table showing the outcomes, and outcomes are, you have K, Is it K? K? KL? KL? Colleagues, are we together?
Yes.
Are we together? Oh, I'm
Yes,
not with
Abel, we are together.
KL, M, and N. So how do you get expected? Expected values. We said you just get N times P. In the question, do we have N? They said 40 independent repetitions. So this is our what? Our N. That is our N. Here N is equal to 40. So you can get 40 and the probability of K. What is the probability of K? 1 out of 5, which is equal to what? Here you get 40 times 3 out of 10. Then
12.
the first one is what?
8.
8.
Then the second one? 12. Then
Yes.
the next one?
4.
40 times 1 out of, which is 4. Then next
16.
times 40 times 40 times
2
2
out
out,
of
which is what?
16.
Yeah, you have what?
16.
Perfect. So these are our expected values. These are our expected values. So you have expected values, you have the observed values. So I think you can get the computed value. Computed values. That the computed value. That is X. That is X squared. That is X squared. By drafting this table again, like this one, because now you have everything. Draft, now you will not do, you will do it in your free time. You draft again and put everything. Observed values, the first one is what? Observed
11.
values. It is 11, next one is 14, next one is 5, next one is 10. So here you will put 11, then next is
14,
next is
5, 10,
next,
10,
then next.
Yeah, done.
So those are the values we have. Those are the values we have. Expected values, this is 8, this is 12, this is 4, this is 16. So I think from here you can complete the number, isn't it?
yes,
You just get the computed value. The total here will be your computed value. Once you get the computed value, you will need value from the table. I need to talk about the value from the table for this question. Value from the table. for this question. Value from the table. What is V? What is the degree of freedom? Degree of freedom. How many? It will remember the formula is number of
The row
rows.
is 1.
Then you multiply number of columns minus 1. So the question is, how many rows do you have? How many columns do you have? Remember, we go back at our question. That's where you need to pick the data from. This is your observed value. Observing these values. How many rows? Only 1, isn't
We
it?
have 1.
How many columns? 1,
There are 4.
3, 5. Rather, there are 4.
4.
There are 4. So there are 4 columns. So in a situation where you just have either one row or
chaplain and fathers in charge of school.
we are saying every time you find that you have one row or one column, one of the bracket will not be considered. If you have one row, it means that you will get 1 minus 1 and you realize that you are getting 0, isn't it? And 0 times any number, you get 0. But when you go to your chi-square table, we don't have as 0 on our chi-square table. When you observe on our chi-square table, we don't have V as 0. It should be either 1 or above. So it means that every time you see that you are almost getting 0, eliminate one bracket. Eliminate one bracket and consider the other bracket. Like for this question, colleagues, we have one row in the question. We have one row. For this question, we have one row. So we cannot say 1 minus 1. We will get 0. So it means that you are going to eliminate that first bracket. We are going to eliminate this first bracket. And we just consider number of columns minus 1, which will be 4 minus 1. Are you getting the reason why I'm eliminating rows? Now that first bracket? Are you getting the reason why I'm eliminating that first bracket?
Yes.
Yes, we are getting.
I can repeat. I said, if you leave that bracket, is the number of rows minus 1. If you leave that bracket, if you leave this bracket, it means that at the end, this will be like 1 minus what? 1, which is equal to 0. And if you get this 0 times, let's say 3, the answer you get as V is 0. Yet on your chi-square table, you don't have V as 0. So that's why we are eliminating. That's why we are eliminating this bracket. So that we don't get V as 0, we eliminate this. But if you realize that you are not getting 0, continue. Leave that number of rows times the number of columns there. Number of rows minus 1 times number of columns minus 1. You can leave it there. If you realize that one of the bracket is not going to be 0. But if you realize that one of the bracket is going to be 0, ignore that bracket. So V is 3. What about our level of significance in this question? In this question, level of significance was what?
0.01.
Alpha is 0.01. This is like 1%. This is like 1%. Colleagues, if they give you, let's say 90%, if they give you, let's say 90%, because I have not talked about that, they may give you here confidence level, let's say 95% instead of 5. They can give you 95% instead of 5. They can give you here 90% instead of 0.01. 0.01 is like 1%. So if they give you those higher figures, always try to get the level of significance by getting 100 minus that percentage. If you're given 95%, if they say you test the chairperson's belief at 95%, always get 100 minus 95. Then the answer you get should be your level of significance to base on. So if they give you 95%, don't base on 95%. You get 100% minus 95%. Then the answer you get, that is 5%. That 5% will be your level of significance. If let's say they give you 90%, you get 100% minus 90%. Answer you get your level of significance. So here the level of significance is 0.01. Penina, kindly mute. Penina? So, what is the value from the table?
0.958.
You stand where you have VR3, then you also check where you have 0.01 from here. From chi-square table, V is 3. V is 3. Move horizontally, look for where you have 0.2. We have 0. What?
Different type. Abel, that is a table.
I am using a different table.
Yeah.
So this is the table. This is chi-square. So V is 3. Then we move horizontally. We look for 0.01, which is here.
11.
11.34.
3,
11.34. So that will be your value from the table, which will be compared with the computed value here. And the conclusion, you will apply either method 1 or method 2. So, colleagues, that's all about question 3. Lastly, question 4, just interpreting it. We need to learn how to, or we need to understand how to interpret that question. The same concepts, but interpretation. Question 4, they are telling us that we use chi-square test and confirm whether the survey study information is consistent with the health center records at 0.05. So this is where you need to focus on as you read the value from the table. So they are telling us that Chabakade Health Center in Mukono district keeps records of elderly people in its neighborhood. Records at the health center show that 40% of the elderly were admitted. 40% of the elderly were admitted. 30% were admitted once. Here, 40% of the elderly were not admitted. Here, 30% were admitted once. Then 20% were admitted twice, while 10% were admitted 3 or more times in 2022. A survey of 150 elderly residents around the health center revealed that 55 were not admitted. Remember, we have the portion, we have the percentage for those not what? Admitted. And they are telling you that 50 were admitted once. 32 were admitted twice. And the rest were not admitted 3 or more times in 2022. So you see that actually it's about interpretation. It's about interpretation. This question, you were given probabilities. This question, you are given percentages, which is like the same. Because this is just information, this is just data. So you are going to draft the table, draft your table, and on that table, what are you going to indicate? Under that table, what are you going to indicate? You try to analyze very well. This portion, this 40%, is corresponding to what? To elderly that were not admitted. So this can be like the probability of elderly that were not admitted. Then here, this is like the portion for those that were admitted once. Then this is for portion that were admitted twice. This is for portion that were admitted 3 times or more. So I can first record that. I have here, I can define rate. Maybe I can say rate X represent number of elderly that were not admitted. Then I say Y B number of elderly that were admitted what?
Admitted one.
Then Z be number of elderly that were admitted twice. Then lastly, after Z, what do we have? Do we have any other after Z?
Nothing.
Let's use P.
No.
I can, Let me use P. No, if I use P, it will not come out clear. Let me use K here. KB, number of, you can use the letter that you normally call your girlfriend or boyfriend. So this is the KB number of elderly that were admitted 3 times, 3 times or more. But don't say that I call my girlfriend K. That is my first name. So after that, we needed to know the portion. X is 40%. We can say with our null hypothesis for this, null hypothesis, I can say P root of X is 40%, which is 0.4. Then probability of Y is equal to, what was the portion? What was the portion? 30%, which is 0.3. Then next, probability of Z is equal to, what is the portion? Yes,
0.2.
0.2. 0.2. Then here, the last one
0.1.
is 0.1. So your alternative hypothesis will be to oppose the null. You will be opposing the null. You will be opposing the null and say this one is not equal to, because that is the only way you can actually state the hypothesis in this question. So from there, you will need observed data, observed values. Are you given observed values clearly in the question? Are you given observed values clearly?
Yes.
For X is what?
55.
You have Y. You have
Z.
Z. Then you have P. No, K.
Okay.
For X is what? Let's see. And
55.
they said as above this, and they say that this survey revealed. So this is your observation. This is your actual data. 55 that were not admitted, then 50 admitted once, 32 twice, then the rest. We will now need to determine what is the rest. So we start here. X is what? We said it is what? X is what?
55.
Then next, Y.
50.
Then Z.
32.
Can you get the rest?
13.
How do you get the rest? Remember, the survey is
13.
so to get the rest. To get the rest, you just get 50, 150 minus 55 plus 50 plus 32. What do you get?
13.
Right. So from that you can get expected values. You can get expected values. And how are you going to get the expected values? Use the same concept here. That expected value is equal to N times P, where N for this question, our N is what? For our question, N is equal to 150, isn't it? Because a survey they told us that a survey was 150, so that is our N. So you will continue and finish. You will just be having come up with your table outcome. You have X, you have Y, you have Z, then here you have K. Then change this and where you and just get N times P. And I believe you'll be in a position to finalize, isn't it? N, like the first figure, N is 150 times what is the probability, what is P? For X, what is P? What is P? P is this one, 0.4. 0.4. Do the same here, 150 times 0.3. So you will follow that up to the end. Once you get the expected values, get the computed values. computed value, which is x squared. You draft this table and fill. Put here your observed values. Your observed values are here. These are your observed values. And your expected values are here. Once you get that, go ahead and do this. Get the value from the value from the table. Value from the table. And what is your V for this question? What is your V? You see that your observed values are these ones. So how many rows? How many columns? How many rows? How many columns? Remember, it is number of rows minus 1. Are you going to put number of columns here? That bracket, are you going to put it there? Because we have only one column. But we have how many rows? 1, 2, 3, 4. So it will be here. It will be 4 minus 1, which is equal to 3. Someone who interpreted this in row form, for him or her, this bracket will not be there. For him or her, will be using number of columns minus 1. But at the end of it all, you will be having the same V. You will be having the same V. So it depends on how you indicated your X, Y, Z, and K in the table. If you indicate X, Y, Z, K in row form, like now one person could be having, let's say, X, Y, Z, K, and find that you have figure here, you have figure here, you have figure here, you have also figure here. So it means that you'll be having one row, but with 4 columns. First column, second column, third column, and fourth column. So it means that ideally here for you, you'll be having a number of columns minus 1. And your answer will be 3. Just that what we don't want is to put another to say that times the number of columns minus 1. If you do this, remember one of the bracket is going to be 0. If you realize that one of the bracket is going to be 0, eliminate that bracket. Focus on only one bracket. That's why you see here I'm just focusing on this. So that will be all for this question. You have level of significance as what? As 0.05. So you will use your data, your chi-square table, which is this one, V is 3. Move horizontally, look for where you have 0.05, which is 7.815. And that will be your level of significance. Level of significance is equal to 0.05, and value from the table is equal to, we said 7 point what? 8 what?
81.
81.
815.
It is what?
7.815.
Perfect. So this is the value from the table, which you will compare it with the computed value. This is VR3. If you move horizontally, 0.5 is here, 0.05 is here. So the meeting point is this one. So colleagues, that's all. That's all for our question 4. So you will just compare the computed value, which I believe you will do. And for conclusion, you will apply either method 1 and method 2 to conclude. Remember, as we conclude, our focus is on the null hypothesis. Our focus is on the null hypothesis. Null hypothesis is the one we put here, the value from the table. Value from the table. That is the one we put here. Compare it with the computed value and conclude. Any other question? Any question about this? If you are given a data, let's say X, Y, Z, and K in number in terms of days. Let's say here you have you observed day one. Day one, let's say they have given you data in terms of days, and this is Monday, Tuesday, Wednesday, then Thursday, and Friday. Let's say they give you this data. Here they give you the figure, the observed value as 10. And here they give you the observed value as 50. Here they give you the observed value as 20. Here they give you the observed value as 100. Here they give you the observed value as 15. If you realize that your data is in terms of days, then to get expected values, because they can give you just this information minus what? Minus probabilities or any portion. They just give you this as the observed. They give you the level of significance. They say you test at, let's say, at 5%. How will you get the expected value? To get the expected value, you will just say, here you expected what? If it is Monday, you observed 10. But how many days are on your sample? How many days are on your sample? These are 5 days. So just add this plus this plus this plus this plus this plus this plus this. You will find that what you are observing is equating to the data in the question. The total here is what? Here, what is the total? If you add
195.
Pardon?
195.
195. 195. So if you're dealing with days or months or what, that's the scenario you will be using. Then just get 195, the total, divide by how many days, how many periods are you dealing with. So here you divide by 5. And that will be the answer. You do that, you do the same 195, it will not change, divide by 5. If you're dealing with 7 days, then you divide by 7. If you're dealing with 6 days, you divide by 6. So that will be your expected. That's how you will be getting your expected value. I saw one of the questions somewhere. So that's how you will handle if you're given days. And that's how this will be your observed value. And the answer you get here, 195 divided by 5, 195 divided by 5, 195 divided by 5. This one will remain constant. This one will remain constant. Are we together? Then after that, once you get your observed values here, and you have your once you get the expected values here, and you have observed values here, then you can be in a position to get the computed value. Can be in a position to get the computed value. Then you go ahead and get the value from the table, where with the value from the table, if you have this information, your V will be, what will be your V? If at all this is our information, our observed data, what will be your V?
195.
No, V, degree of freedom.
To be 4.
You ask yourself, what is number of rows? What is number of
We have
columns?
to be 4.
Number of rows, this is 1, first row, second row, third row, fourth row, fifth row. So those are 5 rows minus 1. That
Which
is
is
your V. V will be equal to 4. Because you have only 1 column here. And if you get 1 minus 1, you realize that the other bracket is going to be multiplied by number of columns minus 1. So that's all, colleagues. That's all for now. That's all for now. Unless if there is a question. Any question?
Yeah.
Yes, go ahead.
From what you have just told us, if you're given data in terms of days, you divide
Yes.
by the number of days. Does that only apply to number of days, or in case they have not
Yes, it
specified?
applies. It applies to when you are dealing with period. If you are dealing with period, they can even give you from January to December. They can give you the data from January to December. So that observed data, you will get the total observed data divided by the number of months. If you're dealing with 8 months, if you're dealing with 12 months, you divide by 12. And that will be constant for every observed value. That's if you're dealing with days. So you just need to analyze the question, of course. You need to analyze the question. If you realize that, okay, you're given days, but they have given you on every day there was a probability somewhere. The probability for each day, then, of which I cannot think they can apply probabilities on days. Unless if it is there, just analyze the question. If you realize that there is no way you can get probability, there is no way you can get probability, the only option would be to do what? To rely on the observed value and days. Get total observed values, divide by number of days. And the figure you get will be your expected value on each observed value. Any other question? Have I answered you?
Yes, thank you.
Any other question? So colleagues, that's enough for now.